Okay, so to start this off, we're going to look at our pH scale, which is the measure of how acidic or alkali a substance is. And in the middle we have region neutral. So if we are less than 7, then we are acidic, whereas if we are greater than 7, then we are alkali, and neutral we are equal to 7. However, bases are a more general term of alkali. So if we consider this circle to be bases, then alkalis are a certain type of bases. So alkalis are soluble bases. So generally bases are insoluble. Alkalis are soluble bases. So of the bases, any which are soluble are then called alkalis. But bases therefore also have a pH that is greater than 7. We can also talk about our neutralization reactions, in which our either acid and alkali or acid and base are reacted together, and our pH moves towards 7, i.e. towards neutral. And so in both cases we end up forming products that should be neutral. So acid plus alkali goes to salt plus water, and acid plus base goes to salt plus water. We can think of some examples of each of those. So an example of an alkali is sodium hydroxide. So this is soluble in water, whereas an example of a base is something like copper oxide, which is insoluble. We can also talk about our acids and alkalis in solution. So in solution, our acids we can think of as being HX. So in acid, remember it's an ionic compound because our hydrogen is a +1, and X could be something like chloride or nitrate or SO4 2-, but then we have 2 hydrogens. This will dissociate, so the ions split up into the respective ions. This is an example of what happens for a strong acid. So for a strong acid, we have full dissociation. However, for a weak acid, we only get partial dissociation, and so it's in equilibrium. And so our acids, they are releasing hydrogen ions. When they go into solution, whereas our alkalis we can think of as being MOH, where M is a metal such as sodium, and in solution that MOH will dissociate into the metal ion and the hydroxide ion. So our alkalis release hydroxide ions. And again, this is an example of a strong alkali, as there is full dissociation. But we could also have a weak alkali where you get partial dissociation. So just to recap what we've covered here, so we talked about what is the pH scale. I didn't write it, but you can rewind the video. Where does acidic, neutral and alkali substances lie on the pH scale? And what is the difference between alkalis and bases? What happens in a neutralization reaction? What are the products of neutralization? What happens to acids in solution? How is a weak acid different from a strong acid? And then what happens to alkalis in solution? So as we are talking about things which can form an equilibrium, so here showing us the weak alkali, equilibrium, so partial dissociation. From what we know about equilibrium, we can write an equilibrium constant for this dissociation. So M plus and OH minus concentrations over the concentration of the alkali that you had to start with. And so we're going to look more at that in that yellow activity.